general philosophy of science is useless in a sense, and let's see whether we can do something about that. You may say, so what? Yes, that's one way of reacting, but there's also the idea, well, if we understand the sciences more in a more general sense, in the German sense, say, of Wissenschaft, namely including the humanities and the social sciences and the natural sciences, perhaps we can get something for economics out of that. And this is the subject of the next chapter. If you Google orientational paradigms, you probably won't find it. Okay, that has reasons which you will understand in a second. Okay, here's the outline. I tell you first what the problem is I want to deal with in this chapter. Then I give you step 1 towards the solution of that problem that you don't know yet. Therefore, you don't understand why this is a solution. That's called orientational paradigms. Then I give you examples of orientational paradigms. Then I make step 2. That's the integration into systematicity theory that you don't also know what it is. That you can Google and you find it. But you can also wait and you get it here and then a conclusion. Okay, so we start with the problem. Now, as I said, none of these positions of general philosophy of science so far discussed really fits economics. However, in Kuhn's framework, one could identify economics as the very best we can do is, together with the other social sciences, as being in the pre-normal phase. That's the only box in which economics could fit. And the question is whether we are happy with economics having there alongside with psychology, sociology, and so on as one of the social sciences. Okay? So if anywhere, then it would be there. And in the literature, for instance, the social sciences have also been described as multi-paradigmatic sciences. You know, that they have their local paradigm, so to speak, or science with coexisting paradigms, and that, of course, corresponds to Kuhn's school in the normal phase, right? You can just reformulate that a little and say these are quasi-paradigms or something, and then we have you can describe certain fields in the social sciences as multi-paradigmatic, and that has been done during the last 10 or 15 years. For instance, political science, sociology, linguistics, education, sports science, and other have been described as multi-paradigmatic. And that would be something that very roughly you could say, yes, that would somehow fit economics, right? Perhaps you're not very happy about that. Let's see why we might be unhappy. Now, in one sense, there is something you might be unhappy regarding economics, because this description of economics as multi-paradigmatic does not fit economics completely, because if you look at economics, it's not just a set of competing schools with different, possibly even incommensurable viewpoints. You can, whatever incommensurability is precisely, don't worry, it's just, you can't really fit it together very nicely. So if you look at sociology, there are really, or psychology, if you compare in psychology, say, empirical behavioristic psychology, that doesn't exist almost anymore, with psychoanalysis, I mean, these people can't talk to each other. It's really completely diverse, completely different viewpoints, for instance. And you find that in these other disciplines that are discussed there as multi-paradigmatic, very similarly. You got these schools and they have almost nothing to do. And that is really somehow different in economics, because in economics there is somehow more unity. Economics as a whole, including neoclassical microeconomics, macroeconomics, behavioral economics, and neuroeconomics, seem to have more unity. And economists, I've heard many times, I heard economists, when they talked about economics in comparison to sociology, they said we've got more unity than the other social sciences, despite their deep differences and dissenses about hundreds, thousands of things, right? It's not that there are big consensus, but they have something, somehow they seem to have more unity than these other social sciences. And that then provokes the question, how can we generally characterize economics? As this field, this scientific discipline, social scientific discipline, how can we characterize it if it's not really good to say it's just multi-paradigmatic? That's the question. So this is a question within general philosophy of science where you want to characterize specific sciences and say what is specific to them in difference to the other disciplines. So here's step 1 towards the solution of that question. And the work I'm referring to, that is done in collaboration with Nikolaus Wittrich, who got a PhD from London School of Economics in philosophy of economics, and he now works with Roland Berger as a consultant. we have discussed that together, and he's more responsible for some of the examples that I'm going to give you. He also influenced me 5 years ago when I set up this class, first because he was at that time at LSE and had philosophy of economics classes when I was a newcomer. So we've done that together. And the paper that we are writing on will be published by both of us. Now, on the one hand, of course, economics is one of the social sciences, and it shares some of their characteristics, namely especially the missing overall consensus. There's no doubt. I mean, there's no overall consensus in economics. On the other hand, it seems to be that economics is closer to the natural sciences than the other social sciences. And of course, you see that immediately in the use of mathematics, that the use of mathematics in economics is much stronger than in the other sciences. So, of course, concerning data and statistical evaluation of data, there social psychology or sociology are very similar. But in economics, if you write down a model, you've got to write down a set of equations. I mean, there's absolutely no way of writing down a model and just verbally. It's just not accepted. So you've got to write down equations. So in that sense, that's very similar, of course, to physics. It's just not enough to talk qualitatively without writing down an equation. Or in ecology, there are many cases, you've got to write down an equation. And there it's much nearer, in a sense. Economics is much closer to the natural sciences than the other social sciences. And then the question, therefore, is how can we place economics between the social sciences, the other social sciences on one side, and the natural sciences on the other? And somehow, some things must be shared. You know, economics shares something with the social and something with the natural sciences. And the point is not simply saying that, but we're making that explicit. And this is step one of the solution. And here's my thesis about that, how to solve that problem is, economics is special by having something special, which is called orientational paradigms, OPs. So the claim is then economics is something that in the same way, well, that makes them different from the other social sciences and also makes it different from the natural sciences. So the first thing is, of course, we're going to talk about what orientational paradigms are. And in the remaining 3 minutes, I just give you a few examples before characterizing what I mean. So there are paradigms, but they're orientational. And here I give you some examples. And later I will give you 3 examples in more detail that you see after I've discussed what I mean by orientational paradigms. But here are some examples. So for instance, expected utility theory is an orientational paradigm. This is now without argument, just giving you a feeling what I have in mind when I speak about orientational paradigms. So expected utility theory is an orientational paradigm. Rational expectation hypothesis is an orientational paradigm. Friedman's methodology of positive economics from 1953 is now a journal. It's a journal. It's a paper in a journal. Is an orientational paradigm. Akerlof's model of asymmetric information is an orientational paradigm. Nash equilibrium is an orientational paradigm. The efficient market hypothesis is an orientational paradigm. The simple DSGE models in macroeconomics, I read that most of the models in macroeconomics are dynamic, stochastic, general equilibrium models. In macroeconomics, they are also orientational paradigms. That's the idea. And the characteristics of the orientational paradigms that I will develop by contrasting them with Kuhn's paradigms, right? Orientational paradigms are modification of Kuhn's paradigms. In Kuhn, remember, Kuhn's paradigms are those that are at the heart of the overall consensus of a scientific community, right? They are the core of the consensus. What is in Lakatos, the hardcore of the research program. And these are the paradigms in Kuhn. And so economists, it is claimed here, have something somehow similar, but also different. It's not really paradigms where you get the whole consensus that you only get in the natural sciences. But the orientational paradigms in economics have a function slightly different because they give a common orientation, right? Therefore the name. So now we go into greater details. Namely, I try to explicate what that notion of orientational paradigms seems to be, and then we'll see whether that's a useful notion for economics or whether it's not. Now, the first characteristic of orientational paradigms is that they are, like Kuhn's paradigms, shared across the pertinent communities. Whatever that means, sharing, right? But in all of the community, people are aware of the orientational paradigms, as in the Kuhnian case, in a normal science phase, all the scientists are aware of the Kuhnian paradigms. Now, this implies that all economists of the pertinent community know the respective paradigms, and some of them are even known to all economists. So if you have orientational paradigms in macroeconomics, some of the micro people may not be really aware of them or dimly aware of them, but some of these orientational paradigms are such that every economist really knows about them. Okay, so for instance, Nash equilibrium or expected utility theory. So every economist knows about them. Perhaps some people do not know the details about Nash equilibrium, but expected utility theories, of course, it's economics 101 in that notation of the American universities. So everyone knows them. That's the first thing. Now, the kind of sharing of orientational paradigms, however, is different from the kind of sharing of Kuhn's paradigms. That makes the difference between Kuhn's paradigms and orientational paradigms. And this is in the following sense, that in the respective community, orientational paradigms are not generally accepted as binding guidelines for further research. You may remember in the Kuhnian case in natural sciences, it's binding guidelines. So if you do, for instance, physical chemistry or theoretical chemistry, quantum chemistry these days, then you just rely on quantum mechanics. And there's no way of not relying on quantum mechanics and using quantum mechanics for your calculations of the properties of atoms and molecules. So there it's really acceptance in the full sense. So everyone works at them, but they are binding, whereas operational paradigms are not generally accepted as binding guidelines for further research. And therefore, orientational paradigms are only seen as common points of orientation. And this is why they're called orientational paradigms. So they just give the economists orientation, and everyone knows these orientation points, so to speak. And that's important, as we will see, for their function. And therefore, orientational paradigms are not fixed points of belief, but fixed points of reference. So you do not believe them. So if you're a behavioral economist, for instance, you do not believe expected utility theory, but you know it and you refer to it in some context. And that's the point. So everyone in economics, at least in a community, has these points of reference, the orientational paradigms. So for instance, expected utility, I mentioned it already, but also in some circles, Friedman's paper, which we are going to discuss later in this lecture course, Friedman's famous 1953 paper, and people refer to that, and the reference doesn't mean that you underwrite everything that's in that paradigm, but it's just you know it and you refer to it critically or provingly or whatever. So the third point, it's very important here, orientational paradigms are not necessarily further developed and articulated as Kuhn's paradigms typically are. So if you look at Kuhn's paradigms, they give you a framework of research to the community, and in that sense, then the paradigm is further articulate, developed, more cases, applications will come up. So one can say, this is the Kuhnian description, that the paradigms are developed, further articulated, and so on. And this is not necessarily the case in economics. Some of these orientational paradigms are perhaps by a minority further developed, but not even that is necessary. They are just there and everyone knows them, and they seem to have some sort of function. So they are thus not a source of normal science in the sense of Kuhn. Remember normal science, consensus about fundamentals, framework, blah, 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 and everyone works on them, works like quantum mechanics, say, for chemistry today, theoretical chemistry, everyone use it, and of course with every new example where the quantum mechanics is successful, it's a further articulation of quantum mechanics in a sense, okay? So this is not the case with the orientational paradigms in which the whole community participates. This does not exclude that parts of the relevant community indeed further develop and apply orientational paradigms, as you know, perhaps, and give you further examples concerning expected utility theory or whatever it is, or Nash equilibrium. There are still people working on it and really developing it further, whereas other people, also belonging to the community of economists, criticize it and say, no, that's false for that and that reason, and I develop an alternative to it. Now, this is also a very important point that of difference between Kuhn's paradigms and orientational paradigms. During normal science, Kuhn's paradigms are not the subject of public and publishable criticism. So if you as a physicist or a theoretical chemist, you can't really publish a paper in which you say that quantum mechanics is wrong. That doesn't work. You will be rejected because people won't believe you. I mean, you must have really extremely strong arguments. And for the last, 50 years, there weren't any arguments where you could really say, well, quantum mechanics, yeah, I don't like it. It's a bad theory. You can't publish that. And if you articulate that too often in public, it's like a biologist, articulating too often in public that he doesn't believe or she doesn't believe in evolutionary theory. Or if you, as a medical member of the medical profession, if you too often publicly in university circles say that, yes, you love homeopathy and how wonderful it is, then many people will say, doesn't work. Okay, so whereas that's the difference now in economics, orientational paradigms are openly and severely criticized by at least a part of the pertinent scientific community. Just remember the anomalies that I told you from Thaler when he started his program describing the anomalies. And the anomalies were just criticism of expected utility theory, saying, look, it doesn't work. It's a theory that's descriptively inadequate. And the fifth item here, this is a similarity to Kuhn's paradigms. Orientational paradigms come in different types, namely different sizes and different degrees of generality. So there may be, very general theories, including exemplars, or rather very specific models. This is the same in Kuhn. I didn't mention that in particular regarding Kuhn, but you'll see then in the examples. Well, for instance, here we have expected utility theory as a very, very broad orientational paradigms for all of microeconomics. And of course, as you know, also macroeconomists sometimes use it in one way or another, versus the much more specific example of Akerlof's model of asymmetric information, which you do not everywhere in microeconomics, but you use it in certain areas of microeconomics. I'll come back, I think, to Akerlof's model of asymmetric information. It's also a very famous paper. I think it has now 33,000 citations, which shows many people really know it and use it. You may not agree with it, but it's something that gives economists orientation. And then finally, like Kuhn's paradigms, orientational paradigms are historical entities. They come, flourish, and go. It may be a long time that they go. So, for instance, expected utilities has not gone, but sooner or later, perhaps in the next 15,000 years or so, perhaps expected utility will also go. So this is just an almost trivial remark. All these things in science are historical entities. And there's another thing that I haven't developed really. The going of Kuhn's paradigms may be their transformation into orientational paradigms. So if you fantasize what would happen if, say, evolutionary theory, Darwinian evolutionary theory, which has been now the reigning paradigm, in its new form for something like 80 years, with no really substantial anomalies that people can't cope with. But imagine it would be falsified at some day, and people would say, well, this is really an inadequate theory. Then I believe that people even afterwards would still refer to the deviations from Darwinian theory. So it may lose its status as a Kuhnian paradigm that everyone believes, to the status that few people or some people only believe it, but then they would refer to it in order to develop an alternative to it by showing what are the differences to the old paradigm. And this is the important function, I'll come back to that, of orientational paradigms in economics. So, now, I think that due to these orientational paradigms, economics has a peculiar position between the natural sciences and the other social sciences. This is what I announced, which should a good general philosophy of science somehow make intelligible. Now, and the more detail, that means economics shares with the natural sciences the common possession of paradigms. But it means something else to possess a paradigm, namely the orientational paradigms, and they are not necessarily seen as the binding exemplars for further research. Some people, a part of the community may treat them as such, but that's not the general attitude, whereas in the Kuhnian case, natural science, it's the general attitude. This is the parallel with the natural sciences, and the parallel with the social sciences is the lack of some substantial common ground that Kuhn's paradigms supply. So you do not have in economics this overall consensus that you have in the natural sciences, at least in some of the phases in the natural sciences. So there is that is explained by the orientational paradigms, and then furthermore, the other social sciences typically lack or have much less orientational paradigms that provides a controversial, though common basis for communication and exchange across all schools and directions within the discipline. So you find something similar. I gave that talk to social scientists who study social aspects of scientific development, and they told me, well, in sociology of science, we also have some sort of orientational paradigms, so it's not a black and white thing. But the point is that I think that the density or the number of orientational paradigms in economics is much higher than in the other social sciences. So there may be a few things that every sociologist know, but I don't really know what that is. But there may be now in the quantitative realm of mathematical sociology, there may things like that. I don't know whether the other sociologists they know it. There may be some orientational paradigms. So I'm not claiming they don't have anything like that. And also physics has some sort of orientational paradigms, and not only Kuhnian paradigms. But the point is that the concentration of orientational paradigms and the importance of orientational paradigms for the field of economics seems to me to be the highest. So this is what is special about economics. Now, I give you now 3 more examples in more details, and there are various examples across the different subdiscipline of economics, and 3 are chosen here. And here, as I said, my co-author for the paper we are writing here is Niklas Wüthrich, and he suggested 2 of those. Expected utility theory, well, this is too obvious that one takes it as an orientational paradigm in macroeconomics, but then Nash equilibrium in game theory is another one, and efficient market hypothesis in asset pricing is the 3rd example. And I want to go through these quickly and show you that they have these properties that I mentioned as the general characteristics of orientational paradigms. So let's start with expected utility theory. It's the centerpiece of post-World War II neoclassical economics. You know that probably in the first week in your first year in economics you are confronted with that. That's the type is therefore, it's a general theory. It's at the foundation of microeconomics. It's clearly a common point of reference for all economists. That's absolutely clear. But expected utility theory is not unanimously accepted as a correct descriptive theory. Right? That's important here. As a descriptive theory, it's not everywhere accepted. Especially, and I mentioned that a couple of times already, behavioral economics deviates from expected utility theory and is typically characterized and presented by its deviations from expected utility theory. And you find that in the 2 centerpieces of the behavioral economics, Kahneman and Tversky's 1979 prospect theory paper that's explicitly developed in contrast to expected utility theory. Its figures and formula are such that the deviations from expected utility are readily seen. And it's a masterpiece in that respect, because this is how it's easy, although it's so unfamiliar to economists, because they're psychologists and they use psychological evidence in a sense. So it's very easy to read for an economist, because he immediately sees, or she immediately sees, what the differences to expected utility theory are. So, and it's quite obvious that they're doing that on purpose. And also, I mentioned it already in the context of Kuhn, Richard Thaler, also Nobel Memorial Prize research program fundamentally based on the identification of anomalies, and anomalies are nothing but deviations from expected utility theory. Right? These are the first, 12 are with Kahneman and Tversky, but his research program on anomalies, which I mentioned. So it's very obvious here that the expected utility theory has a function, although people don't believe in it anymore, and that's orientational paradigms. Now, second example is Nash equilibrium, and it's the mutual best response reasoning. Given each player knows the equilibrium strategies of the other players, no player has anything to gain by changing only his or her own strategy. This is basically the idea of Nash from 1950. And the type of orientational paradigm, it's a general theory, and the references will come at the last slide of this session. Nash equilibrium is a common point of reference for all those people who have are in the game of game theory. There, Nash 1950 has 7,600 Google citations, which is not an extremely large number. If you compare it with the largest number, Theory of the Firm by Coase, something like 53,000. But Nash equilibrium is, of course, much more restricted. It's a smaller little thing. It's in every textbook on game theory and microeconomics, of course. And here's a quote: in the last 20 years, the notion of Nash equilibrium has become a required part of the toolkit of economists, so well known that it does not need explicit citation. This is always a sign that something has been completely absorbed. So for instance, when people refer to quantum mechanics, they do not then cite Schrödinger or Heisenberg or something like that. Everyone knows it anyway. And that's the same with the orientational paradigms or expected utility theory. You don't cite von Neumann and Morgenstern or Samuelson or something. You just know that, right? And it's just part of the knowledge that every student has. Now, Nash equilibrium is not unanimously accepted as correct and therefore as guideline for further research. It suffers from two widely acknowledged problems. The failure of predictive power of Nash equilibrium, so there are many situations in which Nash equilibrium doesn't predict the behavior of the agents, and it's the so-called equilibrium selection problem. And there are, broadly speaking, three solution strategies to these problems with Nash equilibrium. Don't ask me, I don't know the details. This is the example that Niklas Wietrich did, and I read about it, but I can't explain that in detail to you. So there are three strategies how to solve that. One is to redefine the payoffs in a game, and that is, for instance, Fair and Schmidt's very well-known inequity aversion strategy in their model from 1999. Then it's refinement of Nash equilibrium, so you can add something like Pareto efficiency and admissibility, and then solution concepts that are not refinements of Nash equilibrium, team reasoning, where I say we need a different approach and not just a refinement, a slight correction or something like that, amendment. So there are people dealing with that, but also these contrasts are typically developed in contrast to Nash equilibrium, and that shows their function as yes, this is what I'm saying. Oh, I say that here even. Yeah, alternative positions are clarified in relation to Nash equilibrium, and that shows their function. And this is a very important function, as I believe, and I'll tell you more about it in a second. And finally, the example of the efficient market hypothesis that says that financial markets fully reflect all information at a given point in time. This is, of course, an idealizing assumption, but it seems to be very, very important. So it's a hypothesis, the type of orientational paradigm. It's a hypothesis, and it's a common point of reference. This is the claim, what an orientational paradigm is. And for instance, if you look at the original publication, 23,000 Google citations, which is a lot, which is really a lot, then it is efficient market hypothesis in every textbook in finance, in the introduction or in the pricing theory. You find it there. I mean, I guess every student from the second year or so knows it. And it's been, now one quote, it's been a near dogma since the early 1970s. Well, a near dogma, meaning people saying, well, I don't believe it, right? And it's wrong and got to be improved and so on. So it is not anonymously accepted as correct and therefore as guideline for further research because there are no problems, widely shared criticism. The big bubble events.com and the 2007 crash, they don't really fit there with that efficient market hypothesis. And also a consequence of the efficient market hypothesis is that the asset prices follow a random walk, and you have empirical investigations there, and there are many cases in which they do not follow a random walk, which is not then consistent with the efficient market hypothesis. And there, again, there are broadly speaking two solution strategies. One is you defend the efficient market hypothesis by sort of, well, tricks or additions. Empirical evidence can be explained away. You say, yeah, well, it's really not really speaking against the other factors, whatever. Or you have the joint hypothesis testing problem. So there are ways to defend it if you want to keep it. And there is also, as an alternative, behavioral finance, Schiller and Thaler, who developed alternatives to it. But the alternative positions are clarified. Alternative position is clarified in relation to the efficient market hypothesis. Again, it's the same. It stays in economics. People have to learn it because in order to develop the alternatives, you have to see where the alternatives and how the alternatives deviate from the efficient market hypothesis. All right. Now, this is now the situation that seems to me that empirically speaking, the existence of these orientational paradigms with these properties that I mentioned is well confirmed. And the next question then is, what do orientational paradigms do for economics? Why are they there, right? What is specific about them, and why is economics different by having orientational paradigms in a higher density than the other social sciences? Is it advantageous for economics to have orientational paradigms? That's the question. And that's, of course, a question that should be answerable in the context of a general philosophy of science, because a general philosophy of science also should tell you something about the specifics of different sciences or groups of science, and then tell you where the differences come from, what their advantages, disadvantages are, and so on and so forth. So from a meta point of view, when you look at the sciences, then you should have a story for that. And as orientational paradigms are not part of those positions, the great general positions that I mentioned, 20th century philosophy of science cannot smoothly accommodate them. They have no space for orientational paradigms, not a concept that you find there at all. So there is another alternative to these general philosophies of science. It's called systematicity theory, and there the role of orientational paradigms can be understood. It happens that I'm the author of systematicity theory, so it wasn't much of a preparation for me to tell you something about systematicity theory now. But this one on the orientational paradigms is not in this book from 2013, but I'm developing it here, and as I said, I'm preparing a publication. Now, what is systematicity theory? Now, it is a general philosophy of science, but in contrast to those positions that we've seen before, it explicitly, willingly, intentionally covers all research fields, including even mathematics, although it's non-empirical, right? And mathematics is very different from the empirical sciences, including mathematics, the social sciences, the humanities, the engineering sciences, and the natural sciences. And these groups are pretty different from each other, especially the engineering sciences. Many philosophers of science don't have them in focus at all. And the humanities are also very dimly only covered sometimes. But systematicity theory is a theory that is very ambitious by covering all these different fields and have a story about all these different fields in spite of their inhomogeneity. All right. So the main thesis of systematicity, of course I've given a full semester on systematicity theory lectures, so I give you only a very small thing, but it should be enough to get the key idea and how it then applies to orientational paradigms in economics. The main thesis of systematicity theory is that scientific knowledge differs from other kinds of knowledge, from everyday knowledge in particular, by primarily being more systematic. So the standard story in the natural sciences is the knowledge of the natural sciences is produced by something which is called the scientific method, right? So you would say that natural science knowledge is characterized by its methodicity, right? Its scientific method. Now, the discussion in the last 50 years has revealed you do not really find that working of a unified scientific method if you look closely enough into the natural sciences, and therefore this is one of the reasons why I developed this theory, and that theory says, no, methodicity is a special case of systematicity, and being systematic is something more general than being methodical or methodological. Okay, so that's the main story. I can't give you the arguments here, of course. You can read the book. It's 100 pages just for the arguments to show you why this thesis is plausible. Now, the next thing is that thesis looks so simple, but in fact, it's a little more it's much more complicated, but it's a little more complicated for here now, because this thesis covers several dimensions of science or aspects of science. So it doesn't simply say science as a whole or humanities or whatever is more systematic, but it specifies the aspects, dimensions of science in which the sciences are more systematic than, say, everyday knowledge. So for these aspects or dimensions, then, this thesis claims that science has a higher degree of systematicity. So, for instance, descriptions and explanations. So the claim is scientific explanations are more systematic than everyday descriptions. Or scientific explanations are more systematic than everyday explanations. Or scientific predictions are more systematic than everyday predictions, right? So if you compare the predictions of someone, there are special guys in Inner Schweiz who are really meteorologists of sorts, and they have ways to predict the weather. If you compare that with what the Swiss Weather Institute or whatever, or the American or the German, there are some 10 big computer systems who do that. How they calculate, what you then see in the evening at 7:30, if you still look television, but you find it certainly also in the social channels, what the weather forecast is. And they are produced much more systematically, right? Many more data and, complicated statistical computer models and blah, blah, blah. So this is the basic idea. So science is more systematic. If you hear that, you have immediately objections. Read the book, and then you'll find that I answer at least some of these objections. Now, the progress of science, this is now very important. And this is probably for you, again, much more plausible. The progress in science as a whole is then increase of systematicity aggregated over all 9 dimensions. So there are 9 dimensions of systematicity. Read them if you're really interested in it. I don't give them here to you. And if you aggregate the increase of systematicity in all these dimensions, then you have progress in science, right? That's the basic idea. So if a science becomes better in its predictions and explanations and internal coherence and whatever it is, then it's becoming better. That's the basic idea, and that has probably some plausibility. You find detailed arguments in the book. All right. Now, out of these 9 dimensions, this means aspects of science, 2 are especially important if you want to understand the role of orientational paradigms for economics, or wherever they are in other fields. And these 2 relevant dimensions are so-called epistemic connectedness and critical discourse. These are some things, again, where the main thesis says the epistemic connectedness, I'm going to tell you what it is more systematic in the sciences than in everyday knowledge, for instance. And also the critical discourse in science is more systematic than in everyday discourse, for example. So, what is economic connectedness? Now, epistemic connectedness is that different parts of a science cohere in various ways with one another. Whenever you look at a science, there are never completely isolated islands of knowledge. Everything somehow coheres, and you've got to bring it in some coherence, and it may be even tensions, contradictions, but you've got to relate everything to other things. So it's impossible in science that you find something that's absolutely and completely isolated. It's not part. Wherever you look, I never found any sort of example where something is completely isolated, then it's not part of science, right? So, epistemic connectedness now says this is a virtue of science. Different parts of a science cohere in various ways with one another, and then it's quite clear that orientational paradigms increase the degree of epistemic connectedness of various parts of economics because they are a common point of orientation. Right? So you get, because every economist knows of the orientational paradigms, they have a common point of orientation, and they get more strongly connected, different parts, different schools of orientation, of economics. Now, the same holds for critical discourse. This is the social institutions that foster critical discourse in a science. This is a social dimension of science, and what you can see is immediately that these institutions that foster critical discourse are a fundamental part of the social organization of science. So, for instance, conferences, or the refereeing system for journals, or the ranking of journals, and so on and so forth. This is all social institutions whose aim it is to have a critical discussion about the different subjects that are the subjects of the field. Critical discourse, and of course, again, it's very obvious that orientational paradigms increase the possibility of critical discourse because different schools can discuss their differences with recourse to fixed point of reference. So this is really a problem if you look at radically different schools, say, in sociology or in psychology. Then you see very often these people don't even discuss anymore because they don't know. They are so different that the first sentence your opponent says, you say, that's nonsense, I'm sorry, right? That's completely wrong. This is completely outdated, or whatever you say, right? Or this is methodologically absolutely untenable, or whatever it is. So then you can't get into a conversation. But you see immediately that the behavioral economists, for instance, this was probably the largest upheaval or revolution in economics during the last, say, 40 years. They have no problem communicating. They disagree deeply, but they have no problem because all of them, also the behavioral economists, know expected utility theory very well, right? So all these people can discuss, and that's important. So you have an increase of systematicity concerning this epistemic connectedness and this critical discourse. These are two of these 9 dimensions in economics, and probably the others will profit also from orientational paradigms. So that means, according to systematicity theory, if you for the moment accept that as a general philosophy of science, having orientational paradigms is advantageous in comparison to not having them. So this is what you see, and I hear that, so when I talk to Ernst Firm or other economists, they are proud of economics being different from the other social sciences by having more sort of unity. Right? They have more things in common. Although, once you have 2 economists discussing anything, certainly after 30 seconds, they will disagree about almost everything, unless they discuss with other people, Then the 2 economists, again, the rest, the 20 others from all different disciplines, they unite and say what's a friendly word here, how inappropriate or deficient the other disciplines are. But it's quite obvious you have this, but the economists, that's their strength in the observation now of economists whom I talk to, and which is explained by these orientational paradigms. They have more coherence because of orientational paradigms. And you see, because that makes them different from the other social sciences on the one hand, and it is not as strong as the paradigms in Kuhn, where all agree, but you see exactly this middle ground which economics then sits in by having orientational paradigms. So the conclusion is then that operational paradigms set economics apart from many other social sciences. That's clear. As I said, it's not a black and white affair. So I guess in sociology you will find, especially in mathematical computational sociology, you will certainly find certain models that are used there that have the status of orientational paradigms. But overall, if you look at the whole discipline, it seems to me from what I see that economics is really stronger in having more orientational paradigms. Then orientational paradigms don't provide things to a profession that are accepted as valid throughout. You do not get a substantial consensus about the truth of something or feasibility of something, but you could only get them as point of common orientation. This is why they are called orientational paradigms. They give you orientation in what you're doing, either by following or rejecting these paradigms. The positive function of orientational paradigms for our science can be understood in the framework of systematicity theory, when you say that sciences are characterized by these dimensions of these dimensions in which they are more systematic than other forms of knowledge. Then you can understand, if you believe that, at least for the moment, then you can understand why orientational paradigms are a good thing for science. Yes, and here are the references which you can look up. All right. So this is the end of chapter 2, which shows that, apart from the last here, that general philosophy of science was not very successful regarding economics. So it's small wonder that you don't learn almost no general philosophy of science in economics, because the economists decided it doesn't help us, right? You better learn more statistics or whatever it is, or Banach spaces or Hilbert spaces, whatever you need to build your sophisticated models. All right. They are weaker than Kuhn's in the sense that not the whole relevant community believes in their validity. That's the point. So if you try to understand Kuhn's paradigms within physics, for instance, the natural sciences, then you tell a different story, right? They are different and therefore have a slightly different function. Of course, they have all the functions of orientational paradigms, but because they are believed in the whole community, they have additional functions, right? So, as I said, I mean, every Kuhnian paradigm is also an orientational paradigm because everyone knows it, refers to it, blah, blah, blah. But the sort of reference is much stronger because in the natural sciences, then people think this is the only way to go at this particular historical time, right? So you needed a separate story. The separate story has been developed in the book about the Kuhnian paradigms, where I have a chapter in which I compare systematicity theory with other positions in the philosophy of science and show them basically that these other positions are just special cases of what systematicity theory says. But the potential of systematicity theory here is that it can really elucidate something of a science of economics in that particular case that the earlier general positions weren't able to, right? In case this goes through, of course. If you think systematicity theory is nonsense, then you say, forget it. Anyway, yeah. But there has no discussion yet about economics because I haven't published it yet. Potential of systematicity theory is, that's one of these potentials that it has, that you can characterize different sciences and even subspecialties of science by their specific concept of systematicity. So the concept of systematicity is not a fixed one. So if you speak, for instance, about the systematicity of descriptions, right, then you mean different things in different fields. If you say, for instance, you discuss the systematicity of descriptions in economic history, then you typically increase the systematicity of those descriptions if you have more quantitative data on macroeconomic variables, right? Then this becomes more systematic, right? So you say, I want to know what is the development of the economy in France between 1814 and 1860. So a historian of economics may have that, and then you say, okay, let's become more systematic here, and then you add, you have different sources then, and you add more and more, say you get data on households, and then you aggregate them, and then you get new variables, and then your description becomes more systematic. If you compare that, say, in another field, say in art history, you want to say something about, in art history, about the development of painting between 1840 and 1860, quantitative measure will play a very minor role. But you may say, okay, we got to investigate stronger what are the teacher-pupil relationships here in order to understand certain things and to get more detailed and more description. So the point is, the systematicity concept that sounds like just one, concept, it's in fact extremely fluid. And it just depends on the respective field where you look. And therefore, all the different fields are typically different in their concepts of systematicity. So it doesn't only tell you, what is the use, say, for regarding the difference between, say, economics and other social sciences, but it has other functions as well. And now people have developed applying systematicity also to historical cases, and one professor for education, she has used it to distinguish different kinds of schools in education. So people make various uses of it, and this use here, that's the first time I think that you can characterize a science or a group of economics by the specific systematicity in comparison now only to the other social sciences and to natural sciences. So it's well, of course, I hope that this is very, very powerful, a concept, systematicity. Well, I think here it does get some, you get some ideas. So if you look at Danny Roderick's book, whose name I couldn't remember in the very first session, who wrote this book, I think 2016, where he said the science with the models, right? And when you try to understand why has economics so many models, well, many of them are orientational paradigms, and that's their function. And then you can derive this culture of modeling in economics, and you see the difference to the other social sciences, and you can see why economics is as successful as it is, which is limited, of course. Every science is limited success, but you can understand that in terms of systematicity to some degree. Well, this will not make your research in economics better. This is not what I hope. But if you say, I want to understand what economics is, in the concert ocean of the other sciences. If you say this is more something of your general education, or Bildung, if you wish, then you want to know that then this sort of philosophy of science is useful. It is probably not improving your master thesis on whatever it is, if you know systematicity theory. But that's not the aim of that general philosophy of science. It's just giving you a sort of insight in what is happening and what you are doing. Okay?